the form y is a, x minus b, x minus c. This is called x-intercept form. This form is perfectly set up for finding the values of the x-intercepts. The coordinates of the x-intercepts would be at b, 0 and c, 0. Look at the graph, look at the intercepts. Note how the signs of b and c have changed. So if we had y is x plus 3, x minus 5, the x-intercepts would be at negative 3, 0 and 5, 0. Consider the graph below, which is of this function. We can clearly see the x-intercepts as stated above. So if we look at the x-axis here, we can see negative 3, 0 just here and 5, 0 just here. It's not difficult to find the vertex in this form. We know the curve is symmetrical, so the x-coordinate of the vertex must be halfway between the x-intercepts. So we have x-intercepts here and here, so the turning point will be on the line of symmetry, and that's going to be halfway in between these 2 points. So in this example, if we average out negative 3 and 5, we get 1, and we can see that this is x equals 1 here. Substituting x equals 1 into the equation, y is equal to 1 plus 3, 1 minus 5, which is 4 times negative 4, which is negative 16. And we can see from the graph that the vertex is at 1, negative 16. We then know from what we have learned before that the equation of the line of symmetry is x is 1. In fact, we already talked about that. If we go 1 unit to the right from the vertex, so go to the vertex here and go 1 unit to the right, we need to go 1 unit up again to meet the curve. You can see that just in this part of the graph here. So the value of a is 1. As always, the y-intercept is found by substituting x equals 0 into the equation. The value of a will tell us whether the curve is happy or sad. We found it was 1 here, which is positive. If a is a positive number, the curve is happy, and we've seen that our graph is happy. If a is a negative number, then the curve is sad.